grandma passed away and my children were having issues. So
Oh,
I
I'm
had
sorry.
to console them and send them on their way to grandma's. Go to grandma's, you'll feel better, I guess.
Yeah. I'm sorry.
Well, she was pretty old, but it was really unexpected, I guess. She had just had lunch with friends and that was it.
Huh.
So
That was the last thing she needed to do, I guess.
yeah, I think she's 93 this year, so.
Oh, so she's lived a pretty long life.
Yeah. Just getting into my thing there. I wonder where Justin's not on here yet. Nope.
Nope, I don't see him yet. Okay, I gotta find the right window to open up here. Hello.
Hey.
Sorry I'm late.
No problem.
So I had a question on the preparation assignment.
Okay.
On number 4, it's in F, compute the p-value and compare it to the alpha level. But I'm not quite sure, it didn't really explain in the homework how to do that. Because I thought that the applet had to be used only in a normal probability curve.
Yeah, I'm confused on that. I'm like, okay, so what are we supposed to use to find the p-value? Because in the homework it looks like something specific. Does that make sense?
Yeah.
Different from what we've used, but I haven't seen anything. I had the same question, so.
On the video that I watched, it showed that in the calculations that you did, it's like labeled just sig, I think. That's what he said was the p-value.
Oh, okay.
He didn't use the applet. He just had it all calculated on in the SPSS.
Because I was just wondering, because they kept showing a picture, you know, of in the homework of the graph or whatever. So
yeah, the density curve.
I do remember reading that now, though. I'm like, that's the only part I really didn't get done on the assignment. So.
Hey, and I have a question. Did anybody? I think Lorinda, did you ever email the teacher about figuring out the margin of error?
I had good intentions, but then we had it on the test or the quiz or whatever it was, and it was the same thing.
Yeah.
And I can't figure it out.
Yeah,
I can't either.
I was going to if you hadn't already.
Yeah. Why don't you do it? Because
I
meant to.
Because I did it like how we explained in the video and everything, and apparently that wasn't right because I missed it. So I was like, what are we supposed to do? And we have a test this week, so that would be nice to know.
No kidding.
Yeah, so I'm going to just maybe go back to that. Because where did it say that it was sig? Because I saw that the variance.
Let me check. Let me find the video.
I remember reading it. I'm looking. So p-value, it's in the example, the first one.
Okay, I'm gonna
3.3. As it shows you how to put it into SPSS. And it says, let's see, like almost clear down at the bottom. After it says click continue, click OK after you've changed the one-way options, whatever. And it says on the ANOVA table, you'll find the test statistic F.
Yeah, there you go.
The p-value sig, and the degrees of freedom for the F statistic.
In 3.3?
Yeah, so that's section 3.3, where it says how to conduct an ANOVA test.
Yeah.
So it's in the SPSS instructions.
Okay.
So come clear down to after they show you how to do it all in the applet, or in the program. And then the following points will help you interpret the output. And then it says the ANOVA table, the second point after it says that.
You'll find the test statistic F and the p-value
sig.
Yeah, so I guess I'll have to compute one of those things again because I've closed it all out.
Yeah. I was doing the same thing, and then after he mentioned that, I'm like, oh yeah, they did tell us how to do that. So,
Yeah.
Okay.
but the thing that I ran into was in the preparation assignment, I think it was, where it didn't give you the two different things to put into the program, like your variable and your descriptive. Does that make sense? So I'm like trying to figure out. So like
Oh, yeah.
the dependent list and the factor.
Yeah. Luckily,
So,
I
and
guess
then-
I must have guessed right.
Yeah.
Yeah, because I figured out how to do it with the gratitude whole thing, you know, and I'm like, okay, now I'll go through and do it on the assignment, but
On the women poet thing.
or maybe no, it was soccer shoes, just going through the reading. How to make that all
Oh, yeah, on the last one.
yeah.
Yeah.
Because you know, I like to go through it to make sure I know how to do it before I actually do it.
Yeah.
And I'm like, so how did they do that? Because it didn't give you different things to put into. Does that make sense? Like to find the statistics or whatever, or they just did that one different. I don't know.
I'm not sure. I didn't work that problem. My lunch hour ended. I was lucky to get through the first part of it.
I've been sucking up water in between. So
it's your turn, Flood, right?
what it's doing is it's seeping through the floor and the walls because water will find a way in.
Yep. Subwater.
Yeah. Well, we have a well dug and it's about 1.5 feet below ground level. So yeah. But I'm not as bad as some other houses in our area. We drove out to pick up my daughter from gymnastics, and basically any of the houses that are around a field, the house is basically its own island, and probably with 2-3 feet of water in their yard.
And rain and snow forecasted.
We have rain right now.
Yep.
Oh, my husband says it's snowing because he was pumping out our neighbor's backyard again.
Nice. Yeah, we've had rain all day. Not so fun.
Yeah, her backyard's pretty much a swimming pool. But yeah, it's just crazy.
Well, they're not going to have to start watering anytime soon.
Yeah.
I know we're going to be complaining in the summer if it would just rain, but we don't want any more right now.
Yeah.
We're 50 degrees and all of our 3 feet of snow melted in a week. So yeah.
Yeah, pretty much what happened here too. So I'm just opening. It looks like we're going to start on soccer shoes.
Okay, the one that I couldn't figure out how to get to work. Okay, we're on lesson 14, right?
Yep.
So I don't do that again. It's slowly opening. There it goes. I love how it asks us if we participated in the group meeting before we had the actual meeting.
Right.
Yeah.
Oh. Okay, in an ANOVA hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others.
Yep.
Yep.
And number 4 says, what requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. Now I would say the bottom 2. Data in each group are normally distributed and variances are equal in each group.
Well, I think it's the
So they're all positive
because the
all
three.
positive?
because there can't be any negatives in the ANOVA.
Yeah. If the largest oh wait, where did I write that down? All are equal. Where'd my notes go? Oh, here they are.
On the wrong paper.
Yeah. F is right skewed. Oh, that's the difference.
Requirements for ANOVA. The data are normally distributed in each group and the variances are equal. Okay. So we're thinking of the other one, the F.
Mm,
Okay. So it is the bottom two. Because I just read that from the reading.
Okay,
yeah, that's what I was looking at too.
sorry. I'm thinking of the F.
So
Yeah,
to
it's
check
right
if each,
speed, never negative, and p-value is right-tailed. So what are 3 differences? That's what I was looking for, sorry.
That's okay.
okay. To check if each group is normally distributed, do the following. Construct a QQ plot for each group.
Mm,
Yeah.
Okay. We assume the variance in each group is the same if the following happens. The largest variance is less than 4 times the smallest variance.
Yep.
yeah.
The hypothesis is equivalent to conducting 2 independent t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3.
So wouldn't that be 3, 4? No.
No, it would be, I'm going to go back to the assignment.
That's where I'm headed. One and 2, 1 and 3, 2 and 3.
Would it be, it doesn't really say right here.
No.
One
If
error.
if we're following that example, would you do like 1, 2, 1, 3, 1, 4, and then 2, 3, 2, 4? Does that make sense?
Yeah, so how many is that? That's like 7. Wait a minute. 1, 2, 1, 3, 2, 3. Maybe it'd be easier to write down the possibilities.
No.
I think it would be 9, but I'm gonna do it again. Or never mind, not 9.
I'm thinking 6. If I follow that pattern.
Yeah, I would say 6 too.
Because we go 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4.
Yep.
Yep, that's what I just had written down too. So 6. Okay, pulling up the data. Okay. So what's the question?
So the question 8, did you want to read the information or just the question?
Yeah, I think just the question.
Okay, so question 8 is, what is the minimum smallest variance for the 6 groups?
Minimum ice.
So how would you put this one
22.
into
Oh,
the
no.
program?
So you have to go and do that transform.
Oh, it's not done for me?
Uh-uh.
I was hoping it was because they said that they would have, because how it was in the reading. So footwear. That's where I was confused when I was doing it in the reading.
So I think the minimum is 19. That's the, like right after the 95% confidence interval. It has a minimum and maximum, and the max looks to be 48.
Sorry, I'm going through it here real quick. So the smallest variance in the 6 groups. So would that be our standard error that we're looking at? Or what would we be looking at for that one?
Well, I thought the smallest was the minimum, like, variance. Over on the right-hand side.
Yeah, so that would be whatever D is, right? But it says round to 3 decimal places.
I guess I need to look at what we're looking for first. There are 5 types of shoes. Okay, so the ANOVA variance is the standard deviation squared. So the smallest variance,
Squared. So that would be 5.230. So 27.
Go through any.
So would that be 27.353?
I'm just getting my calculator out.
Okay.
Okay, so we're renaming. Are we doing is it the automatic recode?
Yeah, that's what I did.
And you did the footwear, right? And then after that, do you do the analyze?
Yeah.
Analyze the ANOVA.
Oh, the ANOVA one?
Yeah. Because we want to see for each group.
Okay.
I think I still have it open on Safari account. Next thing we'll have to do is make my easy dough. Sorry, my husband's trying to cook dinner in the background too. Oh wait, there's a number smaller. C is smallest. I missed that.
Right.
0.216 squared, right?
Yep. So 27.207. I hope that's right. That's what my notes.
I remember reading something along those lines, so. I'm going through real quick, see if I can see anything else. Yeah, remember the variance is the squared of the standard deviation. It's the square of the standard deviation. But we go by off of the smallest, if I remember right. Because I remember reading something about the smallest one. So I think we do the same thing when we go to the largest one too.
Yeah. I hope so. That's what I'm putting in.
At least we have two trays, right? Well, I guess we have 6.
Yeah.
6 tries, yeah.
53.159 is what I have.
7.21 squared. 53.159.
Yeah. The test for equal variances is satisfied for these data.
I don't know why I can't get mine.
Did you buy the software?
I did.
Isn't it so much nicer than having to try
It's
it?
so much. I hated that stupid server thing. It was the
Mhm.
It
worst.
made it hard.
Well, it looks like the email that she sent out is like, nope, you guys aren't going to be able to use it Excel anymore.
I know. Okay. The test for equal variances is satisfied for this data. So it said 4 times larger, right?
Mm-hmm. Oops. So I think it's false because the smallest isn't 4 times the
I think
largest.
it's false too.
Hey, sorry, I'm really lost on this, but I can't. I'm already forgetting because it's not that I don't understand. I just like don't have. I haven't practiced enough with this program to figure it out.
Not a problem.
Not a problem. No, that's okay. We need to walk you through it. We can.
Yeah, I'm just trying to figure because after you did the because you do the transform and then the automatic recode, right? And then you do
Right.
the footwear one.
Right.
And then you go into analyze, and then you do the one-way ANOVA, the compare means one-way ANOVA, right?
Yeah.
Correct.
And then the footwear code is in the dependent list.
No,
No, it's in the other one.
it's in the
So-
bottom.
So the footwear is in the factor.
And kicking accuracy is the dependent. And then you're supposed to go into options and click in this
Means plot.
statistics, descriptive, and then means plot.
Okay. Maybe that's what I missed. There we go. Okay. That makes sense then.
Yeah. I
That's
usually
what-
play with the
those are-
program the same time as I'm reading, so.
Yeah, those are. I forgot to do those things.
Okay, construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. True or false?
I have not done that, but I will go do it right now.
I have to remember where to find it.
Yeah. The descriptive status statistics.
Yep. And then we just, oh crap. Now what do we put in for the variables? Okay, I have to look at the reading for that one.
I think it's kicking.
Yeah.
He must not be in the right spot because mine is only giving me.
Okay, so we go to analyze. Okay, so it says go to analyze, descriptive to statistics, explore. Now put our dependent list in the dependent and our footwear code into the factor. And then click on plots over to the side. And mark the box next to normality plots with tests. And then click on continue, click OK. Haha. It still doesn't look right. Oh, maybe it's still loading, that's why. Okay. And we
So
want to look at the observed value. I think it's normal. Because it follows that line pretty close.
Yeah.
Yeah, that's what I was thinking.
Some of them further down are, they
Whack.
don't look right, but then they're the deviation from normal.
Yeah.
So
Yeah.
yeah, it looks pretty normal to me. True.
Okay. Perform an ANOVA test in SPSS and observe that the p-value is 0.081. I gotta get in the right part of it so I can see that, because I'm that type of person. I've got to see it.
And see, I don't see it. I don't see 0 point.
Right there in that ANOVA part, it's right off to the right in that SIG. Right there.
Yep.
Point
So
zero.
right there at the beginning, our first set of stuff that we did, in the ANOVA section, it's the SIG.
Oh, okay, I see it there. All right, the little box on the bottom. Okay.
Then remove the SOX data and perform the text again. What is the p-value?
How do we remove the SOX value?
Oh no. Do you literally just go in and delete that whole thing?
So I'm thinking we go back to our original there at the beginning, you know what I mean, that we did?
Yeah. The original data.
Yeah. Did that wrong.
There's got to be another way of deleting it, but I guess this might work. So I get 0.309.
Okay, I think I did it wrong.
Let me check.
So analyze, descriptive statistics, explore, right?
No, I went in and did that and compare means and then the one-way ANOVA again.
Okay, but you have to have a factor in there, don't you?
Well, yeah, it's still going to be the
Footwear code.
Oh, she dropped out, I think. Did she say she got 0.309?
That's what I'm trying to remember. I'm still trying to figure out how she did it. She'll be back in a minute.
Yeah. Yeah.
So how do you go in and find that?
Because what I did was do the compare means and then the one-way ANOVA thing again, and then that's when it gave it.
Are you back?
Yeah.
Yes, we're here.
So did you get it figured out?
So from what I understand, you have to have something in the dependent list and the footwear code. Sorry, my husband's noisy in the background.
The factor is still the footwear code, and then the dependent list is the kicking accuracy. So I just went into the data table and took all of the SOX out. So it didn't put that in the computation.
So you went to the original data table.
Yep.
And did you say you got 0.309?
Uh-huh.
Okay, that's what I got too then.
Okay. So is that you remove the footwear A, B, No.
So in,
You'll
Let me
scroll down and you can see it. It's like down by like number 101. That's when it starts after
Okay.
the
So
socks.
take those 2 columns out in the
yeah,
accuracy too, right?
yeah. So
Okay.
from 101 to 120, just take the numbers out.
Delete.
Well, let me do one more thing.
Okay, I get 0.309.
Yep,
Mhm.
that's what we got.
I just had to know how to do it, what I was doing because, yeah. Okay, the test statistic for an ANOVA hypothesis test is the F statistic. Is the p-value in the area to the right or left of the statistic? It's
The
to the
right.
right.
Yep.
That was easy enough.
Yeah.
All right. Looks like we'll have to open up some hot dog nutrition.
Because we all know it's so good for us.
That's right.
Maybe.
It took a minute for mine to open. Okay, so researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available. Okay, use this to answer the remaining questions. Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. So here we just want to go into the QQ plot, right?
So mine look normal for the.
Yeah,
Yeah,
mine.
mine's pretty normal.
Yep.
So I'm going to answer my top one. The assumptions have been met. It's safe to assume each group comes from a normally distributed population from the QQ plots. And we can also assume that the variations or variances are equal.
Yeah.
Yeah.
So run a test to determine if the mean number of calories is the same for all 3 types of hot dogs.
So do we want to transform or recode this one?
I recoded the type.
Mm-hmm.
Oh, okay. That makes sense.
So I got the SIG for those is 0.000.
Right. That's what I have.
So I'm going to say we have sufficient evidence to claim that all 3 hot dog types have the same mean number of calories.
Yeah.
Yeah.
I'd have to agree. Now let's examine the sodium levels. Construct QQ plots of the sodium level for each of the 3 types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is that big number and the largest is that big number. Have the assumptions been met to use ANOVA? Looks like
Mine still looks pretty normal.
That's what I was thinking.
I got to read the question again. Oh, okay. I got to do my plot thing again. I was looking at the. Never mind. Okay. Yep.
So would we put that first one again? The assumptions have been met?
Yeah, and we can assume the variances are equal.
Yeah.
Okay, the assumptions have been met. It's okay to assume that each group comes from a normally distributed population, right?
Yeah.
Mhm.
Okay, I just wanted to make sure because we've had in the past that they weren't the same, so.
Okay.
Okay,
Number
Okay,
17
then the next
says-
one says, despite the possible problem with the QQ plot for poultry. Oh, so is it wrong? It can't be wrong. Oh, okay. Never mind, sorry. So you decide to use ANOVA to determine if the mean sodium levels are the same for all three groups. So the p-value is 0.179. Right?
I'm checking. Would you say your sig value was?
0.179.
That's what I have.
0.179?
Yeah.
Okay.
So I'm thinking name number 18 is we do not have sufficient evidence to reject.
We lost her.
Yeah. But I'm sure she was saying the B, we do not have sufficient evidence to reject
To
the
reject
claim.
the claim.
Yeah.
That's what I'm going with too.
Yeah.
Hey, she'll be back here in a second.
It looks like she's back.
I'm here, sorry.
It's okay.
We figured out the rest of what you were saying. We do not have sufficient evidence
Yeah.
to reject the claim, since it's the only one that says that.
Okay, who's brave?
I'll do it.
Okay.
Okay, 18 out of 20. So number 10 is wrong, which that's easy because we know it's true because it's a true or false.
Yay. I like
And
this.
then number 15 is wrong.
Then it's probably the.
So it's less than the p-value.
So we're going to reject it, saying we have sufficient evidence to claim that all three hot dog types have a different mean number of calories.
Okay.
Okay. Okay, I will submit. Okay, so we must have still missed number 15. We still missed 15.
Well, we have one more shot. Well, we actually, yeah, to get the right answer. And then, We have sufficient evidence to claim that at least one of the hot dogs, one of the hot dogs types. Okay, here we go. We're going to get 100% this time. Yay, 100.
Okay,
So
so
it
with,
doesn't have to be all three types. It just has to be one out of the three.
So you
we
said it
have
was that bottom one?
Yeah.
Okay.
we have sufficient evidence to claim that at least one of the hot dog types has different mean number of calories, right?
Yeah.
Okay, I gotta open a new quiz up because I leave the other one open so I can just go through and click the right ones.
Yeah.
It's taking its dear sweet time loading.